All right, welcome to this explainer. Okay, let's just dive straight into it. Today, we are breaking down a topic that is quietly powering a massive shift in modern insurance technology, Guidewire ClaimCenter Integration. Now, if you've ever wondered how on earth modern property and casualty insurers manage to process complex claims in literally minutes instead of days, well, this is the secret sauce. We're going to explore what is essentially the highly lucrative plumbing of the insurtech world. It's a fascinating, high-stakes ecosystem, and mastering it's absolutely one of the most reliable ways to build a recession-proof, top-tier career in IT right now. So let's get focused and demystify exactly how this whole thing works. So here is our agenda for today's explainer. First up, we'll look at the Claims Integration Hub. Second, the architecture and core technologies. Third, integration roles and demand. And finally, your Guidewire career roadmap.
Okay, Section 1, the Claims Integration Hub.
To really understand the tech here, we first need to reframe how we view it. You see, ClaimCenter is not just some standalone app sitting on an adjuster's desktop. It's the nerve center of the entire claims ecosystem. So, what exactly is Guidewire ClaimCenter Integration? Simply put, it's the process of connecting ClaimCenter with both internal and external systems using REST APIs, SOAP services, messaging, and events. The ultimate goal, and honestly this is absolutely crucial, is that you want to make the exact right information available to the right system at the exact right time, completely without manual intervention. Just think about it. When a claim is filed, the system instantly needs policy limits, billing details, fraud scores. Integration is the discipline of building those underlying pathways so that data just flows seamlessly. I absolutely love this analogy. It's brilliant. Without integration, ClaimCenter is an island. Imagine a claims adjuster just sitting stranded on that island. Sure, they have a great user interface, but they have zero idea if the customer actually paid their premium because, well, they can't see the billing system, they can't approve a payment because they aren't connected to the banking rails, and they can't flag a suspicious claim because they have no access to the fraud detection engine. Integration is exactly what builds the bridges to and from that island. And when you build those bridges, the benefits are immediate and massive. You unlock real-time processing for instant data access. You enable third-party system connectivity, meaning weather data providers or medical networks can just plug right in. This leads to dramatically faster settlements. In fact, by eliminating manual data rekeying, you can cut simple claim cycle times down from days to literal minutes. It's a real game changer. And all of this culminates in automated straight-through processing, where event-driven rules can assign adjusters, set financial reserves, and even pay out low-complexity claims with zero human touch. Let's do a rapid-fire walkthrough of a real-time ecosystem that a single claim travels through. Imagine a customer gets into a fender bender. Instantly, ClaimCenter pings PolicyCenter to verify coverage. Next, it talks to BillingCenter to figure out the deductible. Meanwhile, details are being sent over to a fraud detection system to score the risk. Once approved, the system reaches out via banking APIs to actually transfer the money to the repair shop, all while updating the company's CRM and ERP systems in the background. It is a massive orchestration of data, and the crazy part, it's all happening in milliseconds. Moving on to Section 2, Architecture and Core Technologies. Now that we know what's happening on the surface, how do we actually build it? What kind of technical plumbing is required to orchestrate this massive ecosystem without the whole thing crashing down? Well, the architecture is built in discrete, highly organized layers. You've got the application layer, the integration layer, the messaging layer, and external systems. Every single design decision a developer makes maps directly to one of these layers. You have your core rules sitting in the application layer, but when data needs to leave, it hits the integration layer. That's your APIs and plugins. Now, if that data is super high volume, it moves over to the messaging layer to keep things flowing safely before it finally reaches the external systems. This structured layering is what keeps data perfectly secure and ensures these critical workflows never grind to a halt. Now, mastering this architecture means understanding a very sharp contrast in how these systems talk to each other, synchronous APIs versus asynchronous messaging. Synchronous APIs, like REST or SOAP, those are for instant request and response scenarios. If you need to verify if a policy is active right the second before moving forward, you use a synchronous call. But what if there's a massive catastrophe, like a hurricane, and suddenly you have tens of thousands of claims hitting the system at once? That is exactly where asynchronous messaging, like Apache Kafka, comes in. It handles massive, high-volume events by putting them into a queue, which allows your systems to process them as fast as they can without blocking the core workflow or totally crashing the server.
But hey, not everything has to be real-time, right? Enter the unsung hero of enterprise architecture, batch integration. Sometimes you just need scheduled, bulk data movement. Batch processing handles the real heavy lifting by processing records in controlled chunks so you don't exhaust the system's memory. Plus, it allows for graceful error recovery. If one record fails, the whole system doesn't just crash and burn. And crucially, this is how nightly financial reconciliations happen, comparing ClaimCenter against billing systems to catch any little integration hiccups that might have occurred during the day. All right, Section 3, Integration Roles and Demand.
So why should you spend hundreds of hours learning this specific tech stack? Simply put, massive market demand, particularly in the Indian IT sector, which serves as a global delivery hub for these exact projects. And here is the number that usually gets everyone's attention: 30 plus locks per annum. Mastering these specific integration skills places you squarely in the strongest pay bands of the entire IT services sector. Because you are dealing with mission-critical financial systems, insurers and consulting firms are more than willing to pay top of the market for developers who can keep these data pipelines running smoothly.
To understand exactly why the pay is so high, let's clearly distinguish between the two main Guidewire career paths. First, you have a configuration developer. They focus on the inside of the application, setting up business rules, UI screens, and writing Gosu code. It's a great role for sure, but it typically caps out around 25 LPA. But then you have an integration developer who manages the outside connections, building APIs, managing Kafka message queues, handling cloud security. Because you're managing complex, risky external connections, integration developers command a significant salary premium, easily pushing past that 30 LPA mark.
And who's actually paying these salaries? Pretty much every major consulting giant out there. Like we said, India is the undisputed global delivery hub for Guidewire implementations. Companies like Accenture, Capgemini, Deloitte, EY, PwC, as well as giants like Cognizant, Infosys, TCS, and Wipro are just continuously hiring integration talent. Why? Because every single legacy insurance company in the world is currently trying to migrate their massive, outdated systems to the cloud, and they desperately need integration engineers to wire the whole shebang together.
Section 4, your Guidewire career roadmap.
All right, so the demand is there, the pay is fantastic. How do you actually get there? Progression in this field is actually highly predictable if you just build your skills in a sensible, structured way. At the beginner level, don't jump straight to the shiny tools. Learn the insurance basics, how to navigate ClaimCenter, and basic data formats like XML and JSON. At the intermediate level, you start building REST and SOAP APIs and writing SQL. As you move to advanced, you tackle event-driven architecture with Kafka and learn to secure your APIs with OAuth. Finally, at the expert level, you are designing the entire integration architecture and deploying it using Kubernetes on the Guidewire cloud.
Let's distill that matrix down into 4 highly actionable steps for you to take right now. Step 1, learn the actual business of insurance so the data makes sense. Step 2, master core Java and the Gosu programming language. Step 3, learn how to build those APIs and manage Kafka messaging. And step 4, gain real-time project experience. Getting formal training, like the structured programs offered out of tech hubs like Hyderabad, combined with actual hands-on project work, that is absolutely the fastest way to drastically compress your timeline from learning to getting hired.
Which brings us to our final thought today. The future of insurance is entirely cloud-native and event-driven. The old days of isolated standalone applications, they're completely over. So my question to you is this: are you ready to stop building standalone apps and start orchestrating the digital future of a recession-proof industry? The tools are definitely going to keep evolving, but the fundamental need to connect systems reliably, that is forever. I challenge you to take that first step toward